In this video, I'll be helping you with the ALEKS problem type called graphing an absolute value equation in the plane advanced. We're going to be graphing y equals 4 times the absolute value of x minus 2 plus 4. And to do so, I'm going to create a table. And similar to other problems, I'm going to graph 5 points on the graph and use those to draw the graph. And seeing the absolute value, I know that this will in some form have a V shape. It could be steeper or wider, and it could even be upside down, but I'm anticipating that the absolute value is going to give me a V shape. And to make sure that I see the V shape, I'm going to start with finding the inflection point of that V. And to do so, this will happen where what is inside the absolute value equals 0. And since for this example I have x minus 2, I want to figure out where that equals 0, and I can do so by adding the 2 over to the right hand side. That gives me an x equals 2. So I'll use that as one of my points to plug in, and then I can just choose a couple of points to the left and to the right of 2. Moving to the left of x equals 2, I can use 1 and 0, and moving to the right, I'll just use 3 and 4. And then to find the corresponding y values, I will just substitute in those values for x. So starting with x equals 0, I would have y equals 4 times the absolute value of x, which is now 0, minus 2, plus 5. Order of operations would have us working inside the absolute value first. So 4 times 0 minus 2 is just a minus 2 absolute value. Next, I can evaluate the absolute value of negative 2, which absolute value would make that a positive 2. Moving to multiplication, 4 times 2 is 8. Bring down the plus 5, so we have 13. So my first point is 0, 13. I'm going to go ahead and graph that on our line. From 0, x equals 0, I would move up 13. That is almost off of my example graph here. And that's the first of 5 points. Next, I will move to x equals 1. And here, I'm substituting in x equals 1 into the equation. And again, working inside the absolute value, 1 minus 2 would be a negative 1. The absolute value of negative 1 is just 1. Moving to multiplication, 4 times 1 is 4. Bringing down the plus 5, we now have 9. So the second point is 1, 9. So on my graph, I'll move to x equals 1, y equals 9. We now have 2 points. And earlier we said we should have our vertex at x equals 2. So that's the next x value I'm plugging in. If I replace x with 2, when I look inside the absolute value, I would have the absolute value of 2 minus 2 is 0. The absolute value of 0 is 0. Moving to multiplication, 4 times 0 is 0. And when I add 5, my next coordinate is 2, 5. So on my graph, I move to 2 on the x-axis and 5 on the y-axis. This should be the point where the v is going to now move in the opposite direction. And to find out, I'm going to move on to my x equals 3. Replacing x this time with a positive 3, I now have the absolute value of 3 minus 2, which is 1. The absolute value of 1 is 1. Multiplication would give us 4 times 1 is 4, plus 5. So again, I have 9. This time the point 3, 9. So on my graph, I move to x equals 3, y equals 9, and I'm starting to see that V shape. However, for good measure, I'll go ahead and plug in the next x value, which is 4. Replacing x with 4, I now have the absolute value of 4 minus 2, which is 2. The absolute value of 2 is 2. Multiplication gives us 8 plus the 5, so again, 13. I now have the point 4, 13. So I move to x equals 4, y equals 13. We can see that this has symmetry here and forms this narrow V shape.